Hello, everyone, and welcome to the Future Space. I'm your host, Daniel Fox. Our guest today is Dr. Beth Shapiro. Dr. Shapiro is the Chief Science Officer at Colossal Biosciences and an evolutionary biologist who specializes in the genetics of Ice Age animals and plants. As Professor of Ecology and Evolutionary Biology at UC Santa Cruz and Howard Hughes Medical Institute Investigator, Beth uses the DNA recovered from bones and other remains to study how species evolved through time and how human activities have affected and continue to affect this dynamic process. Her work focuses on organisms ranging from influenza to mammoth, asking questions about domestication, admixture, speciation, and pathogen evolution. Her current work develops techniques to recover increasingly trace amounts of DNA, such as from environmental and forensic samples. A 2009 MacArthur Fellow, Dr. Shapiro is also an award-winning popular science author and communicator who uses her research as a platform to explore the potential of genomic technologies for conservation and medicine. Dr. Shapiro, Beth, welcome to the Future Space.
I'm happy to be here.
Beth, what would be for you 3 words that capture the essence of space?
So you asked me this question a few days ago in preparation for being here, and I have to say I'm not used to getting homework assignments for podcasts, but I'd like it. Of course, it made me think deeply about not just my work, which really isn't focused on space, but is focused on exploration and sort of going into crazy parts of the world and seeing what we can do. And then how that comes together with the themes of this podcast, the themes of your work, the work that we're hoping to do together over the next couple of months. And I think I've settled on something that I hope you'll find interesting because I kind of hope it sets us up for good conversation. And that is space as nature's next step. This idea that we are part of nature, and the decisions that we make, the actions that we take, the science that we do is part of us being nature, with the value that we all have to want to know more, to explore more, to experience more. And I feel that the push for space exploration that has happened over the last many decades now, but really seems to be gaining intensity right now, is part of that. It's nature's next step, it's our next step, but in many ways it's the next step for a lot of the science and exploration, and for us feeling what it is to be human, to be both human outside of nature and intrinsically part of nature.
Which is almost kind of a setup for the next question. What is the human story of space?
That's a great question. I think the human story is about dreams that demand innovation, about wanting to see more than we see in our everyday. I think space exploration, much like my field, ancient DNA, is about, well, we've run out of stuff that we can look for here on this planet. So where do we go next? And in my world, we go backward in time. We dig up bones and we try to extract DNA from those bones and use that information to piece together detailed pictures of snapshots of the evolutionary history of our species and our planet. And space exploration is doing the same thing, looking into the past by going out into space, but also looking into the future.
It's very interesting. You're the first one who very zeroed in with the 3 words on the very nature of future space, and the work or the narrative that I'm trying to capture is, right, there's a science story of space, there's a technology story of space, the geopolitics, but no one really thinks of a nature story or the human story of space. And the reasoning that I've been having is the nature of the universe is nothing different than the nature on Earth. Right? We think of these systems as separated, but why would nature actually invent something different on the planet? It's just a different scale. And if you're, not that I want to personify the planet, but if the planet has its own arc of life, it started really primal, it was really harsh, and then it evolves or it develops in complexity and accumulates and develops this knowledge, which is life. it would be such a shame to die in billions of years with all this knowledge going nowhere, right? All this investment, all this energy to create something that ultimately goes nowhere other than just this tiny molecule of the universe when there's just this vast system out there. And so now we have, that we know of, the first species who, for a combination of luck and opportunities and strategies, we have one species who is about to take all that knowledge and take it beyond and continue that story of life. And this is us. And that's not science, that's not technology. That is nature. That is the nature of the universe, and where nature works on randomness and trials and errors. There's a certain beauty in it, but it's more out of the balance is acquired through all these pieces of the puzzle working in connection with the others. It's not that things are in balance. It's just that everything is related, and therefore it acquires a certain balance from really far away. And now we're about to take it to space.
Well, we have, but not very far. So we have to take it further. Yes. Yeah, I really love that. And you're describing, like you say, nature is not different. Earth is not different from anywhere else. And what you're describing is evolution by natural selection. You're describing trial and error that creates different forms. Some of them do better than others, and they only do better than others in the context of the immediate moment in which they live. That context would be totally different 100,000 years ago, a million years ago, a billion years ago, and it'll be totally different a billion years in the future. And so nature will keep trying these different things and we'll see what works. And of course, at a macro scale, to our macro scale, which of course isn't a space macro scale, humans are going to do the same thing. We are, just like evolution, going to try lots of different things. And some of it will work now, some of it will work, 200 years from now, some of it will never work. But we can't help ourselves, but trying, because we are part of that nature.
And evolution is not a stop phenomenon, right? We always talk as if like we today arrived at this final point and humans are the way they are and the world around us is the way it is. But in reality, evolution is continuing. And if we fast forward 500,000 years from now, how different do you think the world would look like?
I think it's really hard to predict, but I think the point that you make is really important. When we even talk in conservation about restoration, we're thinking about, we have grasped in our brains a very particular time that we want to restore things to. Often when we talk in the US about restoration, we're talking about restoration to before Europeans arrived. But the time frame that I've worked in ancient DNA is before any people have arrived. 100,000, 200,000, 700,000 years ago in North America, things looked decidedly different. But no one talks about restoring North America to the time when we had several different extinct species of giant horse and giant camels and giant beavers. Well, maybe some people talk about that. Maybe people in my field talk about that. But that's not normally what we think about. You made another point that I think is super interesting, which is this idea that we think of ourselves as the pinnacle, the time that we're in as the end point. When I wrote my most recent book, it's called Life as We Made It, I'd point out that, when we think about evolution as biologists, we're often thinking about the randomness of evolution that we call genetic drift. Mutations arise just by mistakes happening during copying DNA. Most of these have absolutely no impact on the way an organism looks or acts. And the number of animals that in 200 years will have those specific mutations is just random. It's just chance. Unless those mutations change something about the way that animal looks or acts, in which case they're acted on by natural selection, another form of evolutionary change. If those mutations make them more likely to have offspring, they will increase in abundance in the population, and hundreds of years from now, everybody will have them. We know, for example, that there are mutations that arose in human genomes after humans diverged from our evolutionary cousins, Neanderthals and Denisovans, that almost all people, more than 95% of people have. And presumably, those were important mutations to making us look and act more like anatomically modern humans than like our archaic cousins. And those were fixed by selection. I think what's different about now than even 10,000 years ago is that humans ourselves are intervening in this process a lot more than we did before. So, in addition to genetic drift and natural selection, now people are manipulating the external world in a way that we have become a kind of evolutionary force. It's not outside of the rules of natural selection, but it's human driven selection. If species arise that are better able to survive and reproduce in the context of the world that includes a whole lot of people, then they're going to do much better than something that can. It's kind of like when we think back to the origins of domestication in plants, where we get the seeds that very quickly fall off or the seeds that stick to the plant. If you're harvesting things, you want seeds that fall off really quickly. If you want everything to be ripe at exactly the same time, you want them to stick to that plant until it's exactly that time. And some involve one strategy and some plants involve a different strategy. But what's the same about it is they're all strategies that do well because of people. And I think that is new, relatively new on our planet. So there is something different about today, but it's not that we're done. It's that the evolutionary forces are changing.
And as we go to space, we will need to, it's going to be a combination of adaptation, but also engineering, technology that will help us face radiation or longevity or things like that. But it's really interesting how, we romanticize nature because we think that, nature gives us everything. But the reality, just as you mentioned, the difference between us is at some point in our evolution, we stop being at the mercy of the forces that were bigger than us. If you look at any other organisms, their lives are driven by these forces of evolution, eat, procreation, and not being killed. The whales are not migrating these thousands and thousands of kilometers just because they love to travel. They're defined by, well, food is over there, so I'm just going to do all this. And then I need to give birth in a safe environment, so I'm going to go all the way back and I'm going to do, and which is how we used to be as a species also. Right, were driven even in the indigenous species. They were migrating with the food, or they were migrating with the season. Now we've taken what nature gives us, and then we've created a certain stability, and then we build on top of that and giving us predictability. Right, the clothes that I have, the roof over my head, nature did not give us that. We created those additional layers. I always tell to people, if you think that nature is so great, go and give birth in the middle of the forest naked and just let me know how you're going to do. And that is the value that we bring to the table, and we have to remind ourselves that there's an ingenuity, or there's a value to what we bring. Nature can take it to just a certain place, and then we take it and go beyond, right?
I'm going to push back a little bit and just point out that, we're still vulnerable. We can still be destroyed by the forces that exist. We don't have complete control over the elements or over weather patterns or over natural disasters or even over what might happen when we're giving birth within the wonderful modern medical infrastructure that we have that makes it a lot safer than it has been in our history, but also that we are part of that nature. And I think that's the point that I was trying to make. Like we evolved these big brains and the capacity to transform plants into clothing so that we don't have to worry so much about freezing to death, or build complicated infrastructure around us so that we're safe from the elements and protected from being too cold or too hot. But we didn't do that because we're outside of nature. We did that because evolution created these complex beings that are us, and now we have the capacity to manipulate nature in that way. And that is going to be important when we go to space. And I think that is what distinguishes us from large language models of today, is that they can tell us all the things that we have said and make it seem like, oh my goodness, they're going to take over the world and solve everything. But really, they're just helping us take advantage of the things that we already created.
One irony of our relationship with science and nature and ourselves as humans, ever since Darwin connected the dots in evolution and the descendant and the trio with primates and chimpanzees, the funny thing is, ever since then, we've been trying to convince ourselves that we're not just primates, that we're so rational and all the laws of nature actually does not apply to us.
Right. We have to feel special because it's in our nature to want to be this better and smarter than everything else.
Yes. Beth, I'm curious. I was looking at your LinkedIn profile. Your banner is actually mosquitoes with a tent in the background. You got to explain to me where was that and why did you decide to put that on your LinkedIn?
So that banner is a picture of my tent that I took when I was on an expedition to the north central Siberia, the sort of Taimyr Peninsula. It was I think probably 2007, 2008, around that time. But it encapsulates so much of the time that I spent early in the field of ancient DNA, going to weird places and in crazy parts of the world that most people wouldn't get to see, and experiencing things like 7 billion mosquitoes per cubic centimeter, like you get in the Arctic during the summer. That picture was so funny. I liked it because I had a real camera because it was early enough that it wasn't just a phone, and I backed up away from my tent and just unfocused the lens of the camera so that you could get an idea of the depth of field of mosquitoes that you deal with when you're out there in the Arctic. But that's where
It's insane. The ones who don't know the severity of mosquitoes in these regions, the reindeers, one of the reasons why they keep moving, because of the flies. Like they can't stay in one place just because of the abundance of flies everywhere that just goes everywhere.
what was really fun about that trip, speaking to the reindeer, is we were out there for a couple of days when all of a sudden some men turned up at our campsite, which was really weird because we had flown for a very long time in a helicopter and there was absolutely nothing anywhere. And it turns out that these were Dolgon. They were part of the one of the remaining nomadic tribes of people who live up in that part of the world, and they are reindeer herders. And we hung out with them for a bit, and the next day we took them back to where their settlement was because we had these Zodiac boats that could go back faster than it would be for them to go overland. And when we got there, we met them, shared some stories and some food and some laughter. And we had been wearing these full body suits with a face net to keep the mosquitoes away from us. And we set up a little tent that we would eat in so that we could take these nets off of our face and eat without the mosquitoes going up your nose or in your eyeballs or in your mouth, because they will. They have no shame. And when we were around the reindeer, they had about 6,000 reindeer with them. It was the only time that we could take the nets off and breathe the air without the onslaught of the mosquitoes. They were really focused on the animals at the time. And I didn't even think about that until we got back to the camp and desperately had to put my hood back on. But it was fascinating to meet these people, to learn about their culture and see what they were doing. But yes, you're absolutely right. The reindeer there were the targets of the mosquitoes. Too bad for them, but it was really very nice for us for that short period of time.
You can do the same thing even when you eat outside and you have a picnic. If sometimes you grab food and you specifically put it on the ground so that the ants go there as opposed to try to come, and eat your picnic. Some indigenous species will do that when they eat. They will find where the colony is, actually going to put food over there before they start eating so they don't bother. So, Beth, I know that you've had a very interesting opinion about what you're working on now and before you start bringing back extinct species. Share with us now, why is it that dabbling into the evolution is a good thing, not only, for conservation, but for any other advantages that this technology is bringing to the table?
Colossal is the company that I've joined about a year and a half ago, and we have officially announced that we are bringing 4 species back to life: the mammoth, thylacine, dodo, and most recently a MOA project that we launched in collaboration with the Ngaitahu Research Centre, which is one of the largest Maori organizations on the South Island of New Zealand, Aotearoa. And these 4 species, I really like the combination of 4 species that we've chosen because it's a placental mammal. That's the mammoth. That was the first one that was launched. A marsupial mammal, which is the thylacine or Tasmanian tiger, and then 2 birds, a smaller bird, the dodo, and a very large bird, the moa. And what this means is that we have declared that we are going to the moon 4 times. And we get to develop and deploy technologies along the path that have the potential to benefit animal species across nearly the entire animal tree of life. And I'm particularly excited about the work with birds because I feel like birds, despite being among the most endangered species on the planet, really don't have the same suite of biotechnologies that are available to help them as other species do. We can't clone birds, the cloning process that brought us Dolly the sheep, for example, because we don't have access to their eggs at the right phase where we can remove the nuclear material from the egg and insert the nuclear material from the regular body cell that we would then clone, like we made Dolly the sheep. And so as we approach these moonshot goals, we will discover new tools, discover approaches that have application across the board, including for agriculture and human health. And these are really areas where we need biotechnological innovation if we want to get to a future where we have 10 billion people or more alive on this planet and we can feed everyone. And also have a diversity of animals that we share the planet with rather than just being us and some ants and mosquitoes. Because they will survive everything.
And so the dire wolf is not in those four animals?
Well, the dire wolf is not one of our launched projects because the dire wolf is completed. It's
Ah,
getting there.
correct. And you really touch on the core of it, of the value of exploration. You don't know these answers until you have these answers. And then the only way is just basically to go and explore. And people have, when we talk about exploration, they think that it's a conquest of a geographical point. But the reality is just, it's the manifestation of curiosity and discovery. That is what exploration is. And whether it's finding a cure or even during the age of exploration, when people left Europe, they were not looking for North America. They were looking for Asia. They were looking for the realm for spice. And in the process, they found North America. They were like, well, maybe this place is more interesting. And I have a feeling that space is also going to be the same thing. We have the moonshot. We think of going back to the moon, or we think of wanting to go to Mars. And these are these dreams that need to be there, incentivize these grand efforts. But in the process, most likely we will find solutions that make more sense, right? And so it's
We have the analogy from space exploration. We call it a moonshot because of the moonshot, because of our experience learning how much we learned along the path to getting to the moon the first time and how much we're going to learn as we go back. And so I think there definitely are links. There's connections that we can draw between the ways that we're thinking about the world right now. So yeah, the direwolf is a really great project. So we didn't officially launch the direwolf the way we launched the other four because we thought that it would be important to not just say we were having yet another species, but to show that we were actually making progress. And this is a really great example of first de-extinction. And it's in part because there were already so many decades of scientific advances that we could draw on and that we could lean on in the path to the direwolf. We had direwolf ancient genomes. I had worked with labs from around the world and we pieced together a relatively low coverage version of the ancient direwolf genome. So we went back to some of the best preserved samples. There was one in particular that was really well preserved. It was an inner ear bone, and the inner ear bone is one of the best bones to get very old DNA because after the bone is laid down in the inner ear, it isn't remodeled and it's extremely dense. So after the animal dies, it's very hard for microbes to get into that bone and chew up the DNA. And that's one of the main causes of the DNA breaking down into tiny, tiny pieces after an animal dies. So we were lucky enough to have access to an inner ear bone from an extinct direwolf, and we got a much better version of the direwolf genome. And we're able to learn a lot about what made direwolves look different from living species of wolves. We learned, for example, that the two direwolves that we have genomes from probably had very light colored coats, which is not something we would have seen by looking at bones, because you can't see, there aren't any pelts that are preserved or anything like that, but we knew from the sequence of DNA that both of these animals had light colored coats. And so we chose to target a light colored coat when we were bringing direwolves back to life, in addition to other things like a larger size and a more muscular body. So we picked 20 different edits that we were going to make. And we knew that a gray wolf is the closest living relative of a dire wolf. So we took cells from a gray wolf and we used the tools of genome engineering and made those 20 different changes to recreate direwolf specific DNA in that gray wolf cell, transforming that cell into something that was much more direwolf like. And then we transformed that cell into a living animal using the same approach that brought us Dolly the sheep. And that led to the birth of the first dire wolves that have been around in 12,000 years.
The living animal that you chose was not just some random.
We used a gray wolf cell, and we'd use a dog as the surrogate mom for Romulus, Remus, and Khaleesi when they were developing. And that's because we have a lot of information about how to keep dogs very healthy and happy during pregnancy and in captive breeding environment, which again is something that we could lean on here because we are a de-extinction company and a species preservation company, but obviously we care very much about animal welfare and the well-being of the animals that we're working with. And so to have the ability to draw on and lean in on decades of advanced science that would help us make sure that everybody was healthy was a real benefit here.
Are you able to share some of the discoveries that were done along the way that were not intended, but obviously, as we mentioned, right? You go for the moonshot, and then along the way, you're discovering these things.
Some of the things that we discovered about the dire wolf itself, like we didn't know that they probably had light colored coats. And we don't know that all dire wolves had light colored coats. Canids, like wolves and dogs, have lots of different colored coats, but the two animals whose genomes we sequenced, one lived about 13,000 years ago, one lived 72,000 years ago. They lived in different parts of the continent, and the fact that they both had these variants in their DNA that suggested they had light colored coats indicates to us that it probably was at least a dominant color if it wasn't something that was spread around the whole population. And then there are also scientific advances that we made along the way. Making 20 simultaneous precision edits in the genome of a living cell is not something that has been done before. It's a tremendous advance in what we call multiplex genome engineering, and this has implications for being able to make similar changes in living species. For example, if we wanted to help Hawaiian honeycreepers become resistant to avian malaria, which is a disease that we people have introduced into their habitat, these are the types of technologies that we would use to do that. We also cloned the wolf cells that we started with by just taking a standard blood draw from an animal in the field. And when we did this, we used this same approach to take blood draws from wild, we call them ghost wolves. These are animals that have some red wolf genetic background. They're also mixed with coyotes. Red wolves are one of the most endangered species in the world, the only endemic American wolf. And they persist today because of a pretty successful captive breeding program in North Carolina that's run by U.S. Fish and Wildlife Service. But the captive breeding program has only a few founder individuals. They captured individuals in order to establish this captive breeding program from a population in the Gulf Coast of Louisiana. And we had a collaborator, Bridget von Holt from Princeton, who was working down there, and she got an email from somebody who lives in one of the towns where she's working that included a picture of a coyote, maybe, or a different type of canid, maybe, sitting on an airstrip. And the email said, I don't know what this is, but I don't think it's a coyote, and I don't think it's a wolf, and I definitely think it's not a dog. And Bridget, she looks at it, she stares at it a bit, and she goes, actually, yeah, what is that? And went down to study this population. And it's not surprising. This is the place where the red wolves were initially captured to establish the captive breeding program. But it turns out that there is still a wild population of animals there that contains a significant proportion of red wolf genetic ancestry. And so we have taken blood draws from a few of those and cloned them. In fact, we've had 4 animals born that are, we call them ghost wolves from this population. There are 4 animals born that have a significant proportion of red wolf ancestry, and it's ancestry that is not currently part of the captive breeding program. So the technologies that we developed on the way to our dire wolves have the potential of really improving and enhancing the success of the red wolf program, which is, I think, a really beautiful way to show that the technologies that we're developing on the path to de-extinction can help to save living species from becoming extinct.
What I think I understand also with the dire wolf, the ultimate goal was not to bring them back into the natural environment. But is it for the other four species that you are working on? Is actually to put them back into their natural environment and support a natural population?
Absolutely. So with every candidate that is a with every species that is a candidate for de-extinction, there will be a different list of technical and ethical and ecological challenges that need to be solved before we can do this. And so as we're considering candidate species, one of the things that we are considering is whether there is a long-term home for these animals. For the dire wolves, we, as the first candidate species, we were really looking for something where we would have a relatively straightforward phenotype, where we knew that the maternal surrogate would be healthy and where we could spend a lifetime for these animals studying them, making sure that they're healthy, learning about how they interact with each other, learn about how they interact with the habitat into which they're introduced. All of this, I think, is a really critical component for a first de-extinction project. You can't just create these animals and then release them. I mean, not only can you not do that because we all work within the regulatory environments in which we live, and you just aren't allowed to just do that, but also you really want to make sure these animals are going to be safe, that they can interact with other species, with each other, and with their habitat without causing any significant harm. And so for these other four animals, we're working simultaneously as we learn what edits we want to make, how to do this multiplex genome editing, and also the animal reproductive biology, which in many of these species is not yet solved, but hurdles that we will need to overcome. We're also working on identifying locations in their natural habitat where they can be reintroduced. What do we have to do in order to make that safe? For the dodo, for example, we know dodos became extinct, not because people ate them. Probably they did eat them, but there are some notes that people found that suggested they didn't taste particularly delicious. But because when people arrived in Mauritius, they brought things with them, like rats and cats and pigs. And a dodo was a flightless bird. It laid a single egg in a nest on the ground, and that was a pretty easy meal for an introduced rat or cat. And so if we're going to reintroduce dodos into natural habitats in Mauritius, they have to be habitats into which these non-native species have been eliminated or at least are under control. Fortunately, in Mauritius, there's tons of work going into that. The Mauritian Wildlife Foundation, Durrell Conservancy, the Mauritian government really interested in restoring native habitats in Mauritius. And the idea that we will have a dodo someday has really caused increased investment in some of these projects as a way of creating a potential habitat in the future. So there is a benefit to conservation of endangered Mauritian species with just the thought of a dodo, which I think is just really, again, a really great rationale for why it's good to have these conversations. It's good to think about these things. It's good to push the technology in this direction. Just like with space travel, as we think about where we're going to go and how we're going to get there. There's so many problems we have to solve, but saying that we're going to do it allows us to at least write down all of those problems, which makes it then possible to start solving them one at a time, rather than thinking we have to solve everything simultaneously, because that's just too hard, too daunting. But we can do it.
Of course we can. This is what we do as a species. We figure things out. I mean, we're always navigating in uncharted waters, trying to figure out what works, what doesn't work. And there's no manual of instruction that says you have to fail 3 times to get the solution. Sometimes you'll fail 50 times, and sometimes you'll fail just 1 time. And the only difference between an innovation or a solution and a mistake is really just a hindsight, is the outcome. Because your way towards it is usually almost the same. You're throwing a bunch of things on the wall and see, what works, what doesn't. I mean, I know that Sam Harris I haven't listened to him a very long time, but back in those days, he was always asking if we had the capacity to bring back the T-Rex, would you do it or you were not doing it? What would be your Position on that.
Just should we rather than could we? Because I often get asked if I've been spending a lot of time thinking about whether we could, and I have been spending a lot of time thinking about whether we could. In fact, I'm one of the people out there who has gone out into the world and collected pieces of amber with insects in them to smash them up and attempt to see whether there's DNA preserved in them. Spoiler, there is not.
You mean Hollywood?
Um,
Hollywood was not right? Ay, ay,
well,
ay.
not in this specific instance. I think that the challenge with dinosaur DNA is that it's too old, and all of the rocks, all of the bones that remain are actually rocks. The oldest DNA that we've ever recovered so far is a mammoth. It's from a mammoth bone. It's the oldest DNA that we've recovered from a bone, I should say, because there's slightly older DNA that's been recovered directly from sediments. But the oldest DNA we've recovered from a bone is about 1 million to 2 million years old. We don't know exactly how old. It's very hard to date something within that time frame. But this is from a bone that was preserved in permafrost, in frozen dirt. So the animal died, was defleshed, probably by a predator. The bone was buried and then stuck in the deep freeze for maybe 2 million years. And the DNA is not in good condition, really tiny broken fragments, highly damaged, but we know that it's mammoth DNA. Eske Villerslev's group from Copenhagen has been able to recover DNA directly from permafrost deposits from the north of Greenland that may be a little bit older than that, probably older than the first Pleistocene ice age, so older than 2.65 million years, so pretty old. But dinosaurs have been extinct for more than 65 million years, which is really, really much older than we believe we will ever be able to have DNA. So could we extract DNA from a bone, figure out what DNA sequences made a T-Rex, and then rebuild that? Probably not. Now, can we learn everything that's out there to be learned about how we engineer limbs and how we engineer faces and see if we could try to reconstruct one using a different path? Maybe. I think it would be considerably harder. There's a lot of that core body plan that you would have to manipulate, and genes don't do just one thing, they do many things. So if you mess with them doing that one thing, the probability that they have cascading impact across the body that leads to some problem, because evolution is complicated, is pretty high. So would it be possible to engineer something? Maybe. But I think I would want to know what the goal was. So I love the work that we're doing at Colossal because it means that we can discover things that we can then apply to helping people and helping animals become more healthy and survive in a future place. Probably there are things that we could learn about engineering things that existed a longer time ago that will help us as well. And in that case, maybe we do have reasons to want to try to manipulate things in a little bit more complicated or sophisticated way. But for the purposes of having a T-Rex, probably not. What do you think?
I think that technology needs to be used with a better understanding of the why. It's not because you can that you should. I'm not against it, but give me the reason why it would be a good idea, not just for the sake of it.
Well, let me try with one why then, because I get asked this question a lot. And I think that we downplay it a bit, but I think it's important when we think both about de-extinction and about evolution and about nature and about space exploration. And that is the value of awe, the value of giving people something exciting and expansive and outside of their normal day to day to think about. The value of inspiring people, of bringing wonder, of making people feel like they're part of something bigger. And I think that is important. We saw this with the direwolf when the announcement came out, and there was some pushback for different reasons. But one thing that was consistent is kids, schools, mostly middle schools and high schools, we were getting letters and drawings and pictures from teachers and from counselors saying, my kids are always bummed. Like they live in a world where stuff seems to be going wrong all the time, where what they hear about the future is about how their future is going to be worse than their present. And they're the first generation who's never going to get to do anything because everybody who came before them has just screwed everything up. But hearing that there were technologies that were being developed that they could be part of, that meant that their future could be biodiverse and rich and wonderful, was inspirational. That it made them happy. It made them want to participate in their science classes. It made them feel like they could be part of something bigger. And I think that needs value as well.
It does. It's exactly also part of our mission at Future Space, or part of the mission that I've had with Field the Wild, with every stories that I've written, and really the big themes of my work, is we've created such a negative story about who we are as a species and about the future, where we're constantly telling whoever wants to hear it, we're almost a cancer to the planet, and if we're not part of the equation, everything would be such, a paradise, and all we do is destruction. And the solution is actually not to move forward, is to find a place in the past to go back to, as if the past was better somehow. And if you're trying to participate into the community, this is not very inspiring. How can we change that story so that we empower people on moving forward, understanding that the past is the past to learn, it's not the place to go back to, but what's ahead of us? First of all, this is where we have the agency. This is where we have the power to reassess how we want to move forward. But it's also that what's ahead of us is always part of the solution. And we need to change the story of who we are and what our role to play into that equation. Because we are a product of nature. We have a reason, just like any predator into an ecosystem, they have their role to play. We also have a role to play in that story of nature, which brings us back into, your 3 words for space. We're to continue that nature story, and we're the ones, through our technology and our capacity to engineer the randomness of nature, we're the ones who are going to be able to continue that story and bring nature to be on the planet. Yes, I agree. The awe factor has definitely a great value. Beth, what would be your 3 words of wisdom?
I would like to tie it very much to what you just said. And I would say, because of who we are, because of where we have come from and where we are today and where we want to go into the future, and also because we do have a responsibility to make sure that the next generation of people that are going to be here know that they are valuable, they're bringing value, that we're going to go somewhere else. I'm going to say preserve, protect what we have, think about the planet as it is, adapt, because we have to be flexible. We have to be willing to let ourselves make mistakes, but also give ourselves opportunities to grow and change and shift and pivot and expand, because we can't just be where we are. We're also going to go somewhere else. I think that really nicely brings together our 2 worlds as well. So.
I'd like to have your thoughts on one thing. When we talk about exploration, people often say that it's human nature. It's written in our DNA to go to new places. But I often try to bring it back that this is a story that we've created on a force. It's basically life. It's not given to humans only. Every single organism will do everything that it can to feed themselves, or to go to basically to grow and expand. We call it exploration because we've created a story around it. But that force is basically what drives everything in life. What are your thoughts about that?
It's true. It's true of evolution. I mean, people first arrived in North America because they were looking for food. They were following the bison across the exposed Bering Land Bridge. It wasn't because they were exploring, but we could look back on it and we could say, oh, they were the first explorers. They weren't. They were just trying to survive. They were moving into habitat that they didn't know was habitat they'd never been to before. They were just looking for a way to get fed, a way to get their next meal. And maybe that's a little bit of what we're doing now, even though we like to call it exploring, because it's more fun to think of it as exploring than just trying to survive. But yeah, maybe we're all just trying to get by.
I mean, that was the motivations of even the Great Migration from Europe. People did not leave because they were happy. Europe was so miserable at that time that people decided to make a choice, and where, well, the possibility of something better is worth crossing an ocean and almost dying in the process than staying in Europe. And unfortunately,
We see that happening today too. I mean, it's not any different from what's happening today. And this is something that people have been doing throughout our history, right?
it's built within the dynamics of nature. Every single organisms will consume until they can't, and then they have to figure out how to go beyond the mountain, beyond the river, beyond whatever environment. If all our children, grandchildren, and every generation lived in the same house, believe me, there would be a lot of conflict. I mean, even within just four people under the same roof, it's just a lot of fights. So imagine, imagine when you have a population. Beth, it's been a real pleasure. I'm really looking forward to go to experience Mashpee together and then the Galapagos and really to continue these conversations that are absolutely just fascinating.
Same. It's going to be wonderful. Thank you so much.
Thank you.